He's a scary character, this one. I don't even know how you say his name. De moivre. I think maybe saying de moivre is a bit like saying bonjour. I think it's maybe more like de moivre, something kind of French sounding. Anyway, he has this formula for expanding cos theta plus I sine theta all to the n, which does not involve the binomial expansion, which is good. So for example, say we had cos theta plus I sine theta cubed. Using the binomial expansion, that would be cos cubed theta plus 3 cos squared theta times I sine theta plus 3 cos theta times I squared sine theta, I'm just going to put the squared out there, plus I sine theta cubed, and then we'd have to tidy it all up, wouldn't we? Cos blah 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 blah. And imagine if it was a 10 or a 12. It would just be ridiculous. Anyway, luckily we don't have to do that. Well, not if we just want to know what this is expanded, because we can use de Moivre's theorem, his theorem, and it says that cos theta plus I sine theta to the power of n is equal to cos of n theta plus I sine n theta. Isn't that lovely? And I'm going to do a proof by induction on a different video. And we're going to use this formula for two main things. Well, three, but two are the same. Two of them are for trig. So obviously, since it's to do with trig. So we're going to use this formula to help us to write sine to the n theta or cos to the n theta in terms of power, in terms of sines and coses, but multiples of angles. So cos k theta, sine k theta. So there'll be no powers on, instead of having a power, don't like. We'll be able to rewrite this in terms of sines and coses of angles, lots of angles, but no powers on any of the sines and coses. On the other hand, say we've got sine k theta or cos k theta or something like that, and we don't like it because today we are not in the mood for multiple angles. We don't like them. We want powers. So we can go in the other direction depending on what mood we're in. So it will be stuff to do with sine to various powers and or cos to various powers. So we can either have an expression with sines and coses in with no powers but different amounts of angles, or we can have expressions with sines and coses in with various powers on them, and we can go in either direction using this special formula. The other thing we can do is find the roots of complex numbers, which is going to be really useful. Really, really cool way of doing it. So, for example, what's the square root of 1 plus I? Or actually, what's the square root of I even? I mean, what times itself is I? We'll come back to that in another video. So, very, very useful formula. We're going to learn it, we're going to prove it, and then we're going to use it to do triggy stuff, powers to multiples, multiples to powers, and find roots of complex numbers and complex roots of real numbers.